Okay, we retain another integral. This one's from the SwinBee 2019 problem 12. We have the integral from 0 to infinity of 1 minus x over x plus 1 all cubed dx. Okay, the first thing I notice here is just the similarity between x plus 1 and 1 minus x. It's making me think we should be able to force some cancellation here and some simplification. So what I want to do first is just bring a minus sign up front, and that's going to allow me to reverse the sign, write this as x minus 1. But now for this minus 1 right here, I really want this to be a plus 1 in order to get cancellation. So let's change that, but I don't want to change the problem. So in order to make this work, I need to subtract the 2 here, so then we still, 1 minus 2 is still minus 1. And then from here, what I can do is break this up into two integrals. So for the first one, we're going to have just our x plus 1 here, this part, over x plus 1 cubed. Then for the minus 2, I'll just distribute in this minus sign, so now we'll have a plus 2 in front here. And this is going to be, that's not the best integral sign, but anyway, this is going from 0 to infinity, and this is going to be dx over x plus 1 all cubed. But now we can cancel this here with one of these. This is going to become squared. And then now we can actually just do power rule on both these. You'll notice we don't need a u substitution, because if you did a u substitution for this here and here, it's just going to be 1 dx, so it's not really going to do anything. So we're just going to go right to power rule on this. So integrating this, we're going to get a minus is going to come out, so that's going to become a plus. Then we'll have 1 over x plus 1. I'm actually going to combine these two together in a second, so we'll evaluate it all at once. Then I'll have this 2 in front. Here, power rule, we're going to have, this is going to become 1 over x plus 1 all squared. And then a minus 2 is going to come out here in the denominator. But I can clean this up, put it together as just a minus 1 in front. But then here, I think before we evaluate, let's just get a common denominator on this. So what I'm going to do is we'll multiply by x plus 1 here, x plus 1 here. So we can put these together, because then we've got our x plus 1 squared here. Then if our denominator is x plus 1 squared, just putting together these numerators, x plus 1 minus 1, that's just going to be an x. We need to evaluate from 0 to infinity. But when you plug in infinity, because the bottom part is squared, that's going to be going to 0 for the first part. And then for the second part, you plug in 0, you've got 0 over, this is 1, but that's just 0. Therefore, for my final solution of this, 0 minus 0 is just 0. Okay, there you have it. Good problem from SwinBee 2019. Thanks everyone for watching. Have a good day.